So welcome to our Connecting Networks class for this week. We are going to talk about point-to-point connections. Last week we talked about how WAN connections were, even though they're called high-speed internet, are not necessarily high-speed internet. And we're going to go through the chapter and talk a little bit about the two main point-to-point protocols used on Cisco routers, which is HDLC and PPP. First off, these are layer 2 protocols, just like we talked about last week in terms of WANs being made up primarily of layer 1 standards and layer 2 protocols. We're going to talk today about a point-to-point connection, which is literally from one point to one point. The thing they talk a little bit about here are the differences between serial and parallel connections. When you look at a serial connection, which is what these links typically are, they're serial connections, not parallel, you will see that you send a single, clicked the wrong thing. They send a single piece of information at a time on a serial connection, whereas on a parallel communication, you can have multiple channels and you can send up to however many channels you have amount of information. So in the bottom parallel channel, you're sending a byte at a time, whereas before, up above it, in serial communication, you're sending 1 bit at a time, and so it takes much, much longer for data to be sent in a serial connection versus a parallel connection. Looking at parallel communications, one of the things you got to think about is clock skew. There are ways to do parallel communication across many different interfaces. For what we're going to do, though, we're going to talk mainly about our serial connections across a point-to-point link. Now, this is how a point-to-point link looks, especially if you're running with a service provider network. So you got a CSU, DSU. Now, folks, one of the things that I hit the wrong button. CSU /DSU. Oh man, what in the world am I doing here? /DSU. With a CSU, DSU, and we're looking at images.
I can see those images here.
So with a CSU, DSU, in old school, and I'm going to show you this. This is an old school CSU, DSU that has on it a V35 interface. This is a V.35 interface. And what would happen is, in this picture we're showing here, okay, the service provider would pull in a Cat5 cable that would connect into this Ethernet link here, all right, and it would then go into the CSU, DSU, which would provide clocking for your network. And a V35 cable would come off of this to a smart serial interface, or possibly just a DB60 connection for an older type router. Here is a great example, a great picture of it. You've got a CSU, DSU, a V35 cable coming over to a DB60 connection on an older Cisco router. These are not that common anymore because now we have Cisco TSU WICs, okay? And so you've got a WIC that is a terminal service unit, and it goes, you just plug that Ethernet cable directly into it, and then this WIC, which sits inside of the Cisco router, does your clocking for you. But that's what this CSU device is. This is a DCE device, data circuit terminating device, which provides clocking. There are undersea cables. They talk about different types of links. There can actually be a piece of fiber that runs across an entire ocean. So in point-to-point links, basically one of the things is it's nice because you have guaranteed service level agreements, you have guaranteed bandwidth, and in most cases you have a little better service in terms of your connectivity versus using some of the non-point-to-point link setups. Now, serial bandwidth, even though it is only 1 bit at a time, so serial is not multiple bits, it's a single bit at a time, still supports some pretty high bandwidths. Everything from a 56K link. I actually remember when we got the first 56K modems, and we thought we were in heaven. Actually, I remember a 14.4 modem, and we thought we were in heaven. You know, now if you don't have at least a couple megabits per second at your house, you're hurting. But you see how the standards go all the way up to OC1. OC1 is optical carriers, and OC1 is 51 megabit, and then all the way down to OC768, which is 39 gigabits per second. 39 gigabits per second, which is pretty quick, you know, for serial communication. So we've got all these different levels. One of the things here I really have people try to remember is the difference between an E1, which is 2.048, and a T1, which is 1.544 megabits per second. So protocols, layer 2 WAN encapsulation protocols. The default on Cisco routers for serial interfaces is a protocol called HDLC, High Level Data Link Control. HDLC is, it's not supposed to be proprietary. It's supposed to be an open protocol, but everyone implemented their own version of HDLC. So HDLC between two vendors may not work. We have an open standard, truly open standard called PPP, or point-to-point protocol. And PPP really is descended from SLIP, which was Serial Line Internet Protocol, and SLIP had some major issues because SLIP was unable to do static IP addresses, and it was unable to encrypt usernames and passwords. And so that's kind of where PPP came out of. And so PPP has the ability to do PAP and CHAP, which we'll talk about with security. It also has the ability to do dynamic IP allocation. And that's why it was actually used for dial-up and replace SLIP. We also have a concept now that we'll go over a little bit called PPPoE, or point-to-point protocol over Ethernet, which is being used on some DSL and cable modem links to provide authentication of the user account on the modem on the opposite end. Other protocols we have X25, and X25 is an older protocol that predates frame relay. The problem with X25, it is packet switched, and it is able to use in it a large amount of error checking. And it was for remote access terminals, like terminals in an airline system, airline registration or check-in system, those types of things. But it had so much error checking that it actually slowed it down. Frame Relay took X25, ripped out all the error checking and some of the flow control items out of it, and became a protocol that was much faster. And it's still in use today, Frame Relay connections are. And then last but not least is ATM, which is a cell-based 53-byte cell. Again, the only thing I really need to know there is it was designed to move multiple types of traffic, voice, video, and data, and that it uses 53-byte cells, 48 bytes for data, and 5 bytes for the control header. So here's HDLC, and again, here's the standard HDLC, and then here's Cisco's HDLC. So even though there is a, quote, standard, everyone was allowed to implement it in their own fashion, and as a result, it is not compatible between vendors. So this allows, what Cisco did is they developed a extension that allows HDLC to actually work with multiple layer 3 protocols, and as a result, it's not compatible with other vendors. Configuring HDLC, for the most part, you don't have to do anything because it's on by default on serial interfaces. But if for some reason your serial interface gets changed to PPP and you want to go back, you simply type encapsulation HDLC, which sets it to that protocol at layer 2. Now, we've seen this about 4 times now. HDLC is the default encapsulation on synchronous serial interfaces. I would know that. I'm just going to leave it at that. Troubleshooting serial interfaces. Now, this is really true with any interface, not just serial interfaces. But if it's up, well, everything's good. You're hunky-dory. Okay, so up, it's all good. Let's see if I've actually got this in here. Fine. Yep. If it's up, it's good. If it's down, this means, remember, the first item is layer 1. The second item is layer 2. So if it's down, it means you're not getting a carrier sense. You're not getting a carrier detect. It could be that the cable brought in from your service provider is not hot. It could be you've got the wrong cable plugged in. It could be there's faulty cabling. There could be a failure on the CSU DSU. But anytime it's down, that means layer 1 is not working, so I'll start checking those items first. If it is up, down, okay, then I start looking to see if there's a layer 2 problem. In other words, is one side configured for HDLC and one side configured for PPP? Is one side PPP with CHAP authentication and the other side is PPP with no authentication? Or there could be also a noisy line. It could be flapping. It could go up, down, up, down. It could be a timing problem with the CSU, DSU. And there could be a hardware failure. If it's up, make sure there's a difference. It was up, down. Yep, line protocol is down if you're in DTE mode. If you're in DCE mode, it's a clock rate missing. Now, real world, your serial interfaces should not be in DCE mode. This is typically because we're in the labs. And in the labs, you've got to set a DCE in and have a clock rate in order for the labs to simulate a CSU DSU connection between the two devices. If it's up, but looped, it means somebody's probably pressed the loop button on the CSU DSU, which is possible. So typically there's a problem with, but it's really not a problem. Most time this is done to check the local connection between the CSU DSU and the router. And if it's up, down, disabled, it's probably a service provider problem. They haven't turned the link on, or you have a problem with the router. And if it's administratively down, then you just have forgotten to turn the port on. Remember, Larry, that all ports on a router are down by default. They are not up. So something kind of important to know.
Okay.
This is a really cool command, especially if you don't have physical access to the device. You can do a show controllers and then the serial interface, and it will tell you what type of cable is connected. So in this case, I know that a DCE cable is connected to the router, and so I need to put a clock rate on this side. When we are doing labs in NetLabs, and I'm going to go ahead while I'm here, I'm going to go ahead and log in real quick and start us a reservation. Well, maybe I will. I don't think there's going to be any. I think all my pods are taken. That doesn't happen often. Yep, 1, 2, 3, 4, 5. All 5 pods are taken. Oh well. Very unusual for that to happen. But when you go in the lab, you'll see needing to put a clock rate on that serial interface. We have a packet tracer, and then now we're going to talk about PPP. Point-to-point protocol is obviously designed to work on point-to-point links. It is able to support multiple network protocols at layer 3 by using a special thing called NCPs. In fact, believe it or not, the way PPP works is it is designed originally to be a dial-up protocol. So there's a link control protocol portion, so LCP, and this does link establishment, link maintenance, link termination. And then once that's up and running, it passes control over to the NCP, network control protocol, for the configured layer 3 protocol. Obviously, IPv4 and IPv6 are the two most common. However, it does support IPX, SPX. It supports AppleTalk, SNA. So it does support others. So if you ever needed to run those protocols across a point-to-point link, you can do that with PPP. What are some of the advantages? One is it can do what's called link quality management. So you can actually monitor the link, and if there is a certain number of errors in percentage across the link can be rerouted or taken down so that you'll be made aware of it. So that's one thing, it can do that. The other big advantage of PPP over HDLC, other than multi-protocol support, is security. You can actually set up a authentication between the two devices so that they will authenticate each other across the link before they will exchange information. Here's our layered architecture. Again, you've got the physical layer. It can run on synchronous or asynchronous, and that basically is two different types of modes that you would be running across on the physical media. Then you've got the link control, which does, again, link establishment, maintenance, and that establishment also includes authentication. And then once that is up, then NCP comes up, the Network Control Protocol. So if the LCP phase never works, then you'll never get to NCP. And you'll see that when we start looking at the protocol itself. So we've got LCP to handle the size of packets, so MTUs. We've got it doing looking at common configuration links, looking at if the link is not functioning correctly, sending that information, and also dropping a link that's no longer in use, or authenticating and re-authenticating. And then once you get up into the IP or Network Control Protocol, you got IPCP and IPv6CP. These are v4, v6. These are used to pass information from layer 2 up to layer 3. And here are the different protocol numbers. You don't need to remember these. These will be in the actual field, the NCP header, to tell it where to pass it up to. So 21 is IPv4 and 57 is IPv6, or 80, 21, 80, 57. Here's a frame. You'll notice it's got a flag, so start of frame sequence. It's always 0, 1, and then 1, 1, 1, 1, 1, 0. The address binary set. Notice it's set for address is always set to 1 for broadcast, because you don't need an address for the other side of the link. This is a point-to-point link. If it goes out the left side, it gets to the right side. You've got the control that handles your sequencing, and that's the being able to use the user data being sent across and received in sequence. The 2-byte field that tells what's going to be in the network control portion, and then your data, whatever's in the data, and then a final frame check sequence, which is just like a normal Ethernet frame. It has a frame check sequence that determines if the frame is modified or damaged in transit. We'll blow through that. All right, so here's our PPP session. LCP, Link Control Protocol, sends out a phase 1, shall we negotiate? Phase 2, if link determination or link quality is actually turned on, it will say let's do link quality. If it meets our standard, yes, we will establish a session. If not, we won't. Again, that's an optional item. It does not have to happen. But then once those items are done, we get to phase 3, which is our network control protocol negotiation. So, hey, I'm going to be running both IPv4 and IPv6 across this link, running PPP, and the other side would say, okay, good, we can do that. And LCP has the ability to actually reset and drop the link. So here it is. As far as establishment, LCP configure. There'll be an LCP configure act. In other words, here's all the things I want to do: authentication, link management, quality, those types of things. The other side will say, okay, I agree. LCP comes up, and then NCP will take off and start running. At this point, they do an echo request, echo reply, and then they have, during the entire exchange, okay, you do have data exchange and the ability to send the data and also change or maintain the link as it's up and going. And then finally, you do have code reject, protocol reject if you get an invalid frame or a non-supported NCP frame across the link. And then you got link termination. We just say, oh, okay, we're going to terminate, and then actually terminate. Now, this doesn't mean that the interface goes down. It just means at that point, there's no active PPP connection between the two devices. And that's because PPP was originally designed for dial-up. So because of that, PPP has some different options. One is authentication, and we'll talk both about PAP and CHAP, but I'll just tell you real quickly, PAP is not secure because it sends the passwords and username in clear text. CHAP is secure because it doesn't even send the password, it only sends a hash across the link. We have the ability to do compression on the link of data, and we also even have the ability to do what's called PPP Multilink. And back in the day, a long time ago when it first switched over to PPP, you could actually take two 56K modems and do a multi-link with them and end up with a faster connection than if you just had one 56K modem. Now, this NCP operation, they get into a little bit of detail about it, but not a great deal. But basically what happens is once LCP is configured and up, the NCPs will request transferring data at the NCP layer. In other words, if you're running IP version 4, there will be an IPCP, so an Internet Protocol Control Protocol configure request. If the opposite side supports IPv4, it will do an ACK. You can then send IPv4 data, and then NCP will terminate that IPv4 connection. Okay, and then finally, LCP can terminate the entire link. So for each one of your network control protocols, this process would be going on. So if you're running IPv6, you would have an IPv6 control protocol configure request and an IPv6 configure ACK. Likewise, if you're running AppleTalk or any of the others, you would get that. Now, IPCP does negotiate compression, so that's compressing the TCP headers, not the entire data, just TCP headers. And also it allows you to specify IPv4 addresses for routing across that link. So it just handles any of the parameters for the layer 3 protocols that are dealing with IP. Hey, Sandella, how are you? Just going over a little bit of PPP NCP operations. So here we're talking about the different types of authentication, what types have PAP or CHAP, all of that is an option. Okay, so option 3, 5, or 6, you have to remember all of these. But basically, we're going to look at do we have authentication? Are we doing compression? What is link quality management? What is it set to? What is our callback net? That is, there used to be a way where you could dial in and have the modem bank call you back. That was used to save money. And then multi-link. That's another possible item that can be an option inside of PPP. The beauty, though, is here's how simple it is if you want to run basic PPP. Go to each side of the link and type encapsulation PPP. Bingo, you're running PPP. You don't have any options. You're just running basic PPP. It'd be really good if you had a Cisco router on one side and a Juniper Extreme on the other side or some other vendor on the other side, and you needed to connect a point-to-point link. You could do that. If you want compression, you set that as an option. Predictor or stacker. And one of the things that, you know, they don't even really talk about this in the curriculum anymore, but one of the things that I used to remember was, I said, I use a sentence, the following, or use the following sentence. I predict, you can remember that predictor uses more memory than stacker. So the predictor compression uses more memory and stacker compression uses more CPU resources. So that's how I remember that. They don't even really ask you that in the curriculum anymore. So. You can do a quality. This is where it will look at the percentage of the link's error messages and see if it meets it. As long as the link quality is 80% or better, in other words, there's not more than 20% error messages, the link will stay up. If it goes above this, it will actually drop. And it is set as a percentage from 1 to 100. And that's to show you doing a little quick thing there. Multilink, PPP multilink, and then you have to do, you actually create a multilink interface, put an IP address on it, and then you create, say, PPP multilink, and then make a PPP multilink group, and then assign interfaces to that group. This is very similar to a concept we're going to learn about called Ether channel. You're basically aggregating multiple links together. In this case, you're aggregating it not with Ethernet, but with Multilink PPP. If you want to take it out of it, you do no PPP Multilink and get rid of the PPP. The Multilink interface itself is the one that gets the IP address, not the physical interfaces. They have no IP address on them. They just become physical channels inside this Multilink virtual channel. Verifying PPP. Show interface serial 000, you will see encapsulation PPP, LCP open. If LCP is open, then that means it's up and running. And then you can go down and see what other network control protocols are running. Right now, you see IPv4, v6, and CDP are all running, and CDP6 are all running. And CDP is Cisco Discovery Protocol that we'll talk a little bit about, or we have talked a little bit about in scaling. Okay. So show interfaces, show interface serial, and show PPP will show you all those things, and they have you go through and see it. Show PPP Multilink will show you a Multilink interface, and will show you what ports are in that Multilink interface. Pretty simple, pretty neat. Now, another great feature of PPP is the ability to do authentication. Now, I'm going to tell you, PAP is really not safe because it does send the username, password, and clear text. It does authenticate the other side, so it is authentication. But PAP is something we really don't want to use in the real world. What we want to use is chat. And what chat does is it does a three-way handshake. It will do a challenge. So when a router goes to connect, there'll be a challenge. Say, hey, we're running chat. Send me your username and send me a username and password hash. We'll send that across. R3 will compare that to information in its database and either accept or reject the authentication. It's really good because chat also does authentication both ways. So the central router will authenticate the remote, and the remote will authenticate the central. Whereas with PAP, only the central or the remote can do authentication. The other thing that's better about chat is obviously it sends only a hash, not the full password across the link. And last but not least, chat actually does periodic re-authentication. Okay. So, PAP, you go in, set up the username, password, and then you, on the opposite side, you put in a username, password in the local database of the central router, and it will then authenticate that particular remote router and say, okay, we will now talk PPP with each other. They talk about it's not really strong. Some places there can be used, but it's a large base of clients that don't support chat. So if your clients don't support chat, you would have to use PAP. I mean, almost everything does support chat now, so I don't really know. Possible incompatibilities between chat vendors or vendors with chat. And maybe you just want to do this so you can do a password capture and show security issues. Pretty bad reason to use it, to be honest. So in this, in chat, what you've got, the remote router, or central router challenges the remote router when it comes up. The remote router responds by sending its chat username and a hash values based on its chat password, and we'll talk about what that is. It can be the enabled secret, or it can be an actual set password. And then the central router will look in its local database, will take the configured password and hash it with MD5 and see if the two match, the hash that was sent from the remote router and the hash that is computed using the local user database's password. If they match, chat will come up and work. If they do not, it won't. Okay. The beauty is too that chat, this is that random re-authentication that it does. It does a variable challenge value that's unique and unpredictable, which means every, even if someone's able to grab the credentials and create a man-in-the-middle situation, periodically chat will force a re-authentication, so they would have to try to grab those credentials again. And you can even set it up to where you can change how often that takes place, but by default it's random and variable. So we're going to go into the interface, and this is important that this is an interface command, and we're going to turn on authentication. And we can do it in multiple ways. We can do PPP Authentication CHAP and only allow CHAP. We can do PPP Authentication PAP CHAP, which will allow both CHAP and PAP, or try PAP first then CHAP, or CHAP first then PAP, or just PAP. So all different types of options. Real world, we really should just use CHAP to make things secure. So here's how we're going to do it. We're going to go in and on R1, we are going to configure a username and password for the remote router, so R2. And it's going to be some password that we set. In this case, we're going to make it same one on both. So username R2, password is same one. We go into 0000 encapsulation PPP, very important. This is PAP, by the way. PPP Authentication PAP, and then PPP PAP sent username R1, password same one. And so R1 will send its, when challenge will send its username of R1 with a password of same one. On the opposite router, you'll see that there's an entry in the local security database for R1 with the password, okay? And then on R2, you're doing PAP and you're sending your password that matches what's on R2. It is not very secure, but it is one way of doing it, and it actually authenticates. Now with CHAP, it's a little different. There's you can go in and do a username, R2, password, same one, okay? So you can set the same password on both sides and do PPP Authentication CHAP, and that sets up PPP Authentication with CHAP. Now, there's a couple ways you can do it. You set the same password, and then that'll be the one that's sent. It can also be the same as the enable secret password, so to use the enable secret password when it sends it. There's a way to do a PPP CHAP sent username and a PPP CHAP sent password. Those are possible too. But you're going to set that up. Now, when we start troubleshooting interfaces, the number one problem is one side is set HDLC, one side is set to PPP. So you've got an up-down situation, or one side is set to authentication and the other side isn't. And when you debug PPP, you'll see LCP failing. You'll see LCP go down. And that's very common. You may have a link quality set that you meant to put 80 and you actually typed in 8, and that's causing an issue. Most time though, with what we do, you do a debug PPP packet, you're going to see what's going on and why it's not coming up. So LCP is, this is actually open, so it looks to me like it's working. So PPP is open. Debug PPP negotiation. See, this is going through. Say it's authenticating. Here's the challenge, and then you can see is it success or not. And then you see this actually opened up IPCP, so authentication worked, and you've got IPCP up and running. And if it doesn't work, you will see it. You will see the error message that says, and here it's, the link is looped. So maybe somebody hit the loop on the CSU DSU. Or with authentication, you'll see that there's a problem. Unable to authenticate, you see unable to authenticate, username pioneer not found. So in other words, you haven't placed the password for the remote router into your local router's database. And that will cause this error. And will cause the link to flap. So it's challenge, other code values, challenge, response. These are code value 4 is a failure. Code value 1 is it's issuing a challenge. Code value 2 is a response. Code value 4 would be a failure. So, and then you got ID 3 could be the number per LCP packet, and then on down through showing the header length. That's the IP number ID for that packet. You got a lab on that, and really, folks, that is it for PPP. So this is another short chapter, an easy chapter. Not a great deal that you've got to worry about with PPP. The labs should work pretty good for you. Should be pretty easy to knock out. Any questions about PPP?
Not on my part.
Sandella, I'm sure you don't have any on PPP. It's so simple.
No.
You probably don't even see it much anymore.
I don't, and the only time I've seen, you know, the multi-link bundles of it is on some of the old, you know, the legacy stuff, like I say, for the work at CenturyLink.
Oh yeah, real old stuff.
Yeah,
So,
yeah.
Definitely. All right, sounds good, folks. I'm gonna call it a day then. I'll put the video up as soon as it gets done for the other students in the class, and I'm going to real quickly stop sharing. Hold on one second, and I'll stop the recording. And then you can ask me any questions you might have relating to the class.